Welcome. This is more on graphing rational functions. Remember, when you start to graph rational functions, you need to find vertical asymptotes, horizontal asymptotes, your x and y intercept, and any other key points that you need. So remember, vertical asymptotes, you set the denominator equal to 0 and solve. Now, this is a quadratic equation. You could use the quadratic formula. I realize that x times x is x squared. Factors of 2 that subtract to give me a negative 1 are 2 and 1. Since we are subtracting, the larger number takes the middle sign. Then, setting each of those equal to 0, we have x equals negative 1 and x equals 2. I would suggest going ahead and putting the dotted vertical line on your graph using a straight edge and labeling what your lines are. So far on my graph, I have x equals negative 1 and x equals 2. I have the x-axis and I have the y-axis. Now, horizontal asymptotes are a little bit more difficult. In step 1, you look to see, are the exponents the same? Are they different? And in this case, they are the same. If the exponents are the same, you take the numbers in front of your x squared and you divide them. 1 divided by 1 is 1. Therefore, our horizontal asymptote is 1. When I put in the horizontal asymptote, I have now divided my graph into 6 parts. And by finding the key points, I know where my actual graph is going to be. To find the x-intercept, you set the numerator equal to 0. Therefore, I'm at the point 0, 0. To find the y-intercept, you replace all of your x values with 0 in the original function, including the top, everything. And anything divided into 0 is 0, and we knew that 0, 0 was a point. Now we have to find some other points. I don't know from here where my graphs go to the right and to the left. I am going to start a t-chart. Since x equals 2 is one of my asymptotes, I am going to find out what's happening at f of 1, at f of 3, and this tells me if I go above my line or if I turn and go below the line between 0 and 2. And I also need to know if it turns down at the, say, negative half mark. And then I need to know what's happening out to the left of negative 1 or at negative 2. So those are the points that I'm going to be looking at. And I substitute those into my original equation. It's negative 1/2 quantity squared divided by the negative 1/2 quantity squared minus the negative 1/2 minus the 2. And if you have a calculator and your teacher lets you use one, then by all means, use the technology. If your teacher doesn't, then you're just using the orders of operation. The negative 0.5 squared is going to be a 2.5. And you would do both the top and the bottom. When you evaluate the entire bottom and divide it into the top, you're going to get a negative 1/5 or 0.2. I substituted in the negative 1/2 and I'm at a negative 0.2, so I'm safe to say that my graph is going to go down on that side. When I substitute the 1 in, 1 squared is 1. 1 divided by 1 squared minus 1 minus 2. So I'm going to do the denominator, and I'm at a negative 1/2. I have substituted in a 1, and I'm at a negative 1/2, which is about right there. And I'm going to connect it with a smooth curve. Then I'm going to put in the 3. 3 squared is 9. 9 divided by 9 minus 9 minus 2 is a negative 2.25, or 9/2. And when I substitute in the negative 2, a negative 2 squared is 4. Divided by 4 minus the negative 2 minus 2. 4 plus 2 is 6. 6 minus 2 is 4. 4 divided by 4 is 1. When I plugged in the 3, I got the negative 2.25. When I plugged in the 4, I got out a 1. Here I am at 3. Here I am at negative 2. I'm going to go up to 1. And at 3, I was down at the negative 0.5. 2.25. Now, I'm going to check 3. 3 squared, 3 squared, minus 3, minus 2. It's a positive 9/4. I thought something was wrong. The reason why I thought this was incorrect was because I only have the one X-intercept. When I substitute the 3 in, I need to be above this line, 1, 2, 2.5, 2.25 rather. Then when I substitute in the 2, I am above the line here. Now, don't get confused. You can cross over your horizontal asymptotes. That's perfectly all right. Moving on to our next example. Vertical asymptote, we set our denominator equal to 0. Again, you could use the quadratic formula. I just used the square root property since there was no b term. The horizontal asymptote, if the exponent on top is smaller than the one on the bottom, then the y equals 0 is going to be our starting horizontal asymptote. To find the x-intercept, we substitute x equal to 0. And so x equals 0 is 0, 0. For the y-intercept, we substitute a 0 everywhere there's an x. 0 divided by negative 4 is the point 0, 0. I'm going to start using my card, drawing my vertical asymptotes, my horizontal asymptotes, and the key points that I currently know. Since these are the only points I know, I need to find other key points or key values. Since the x-intercept and y-intercept are the same, I need to find out what's happening. If I substitute a negative 3 into my original graph, why negative 3? Because negative 3 is to the left of my first vertical asymptote if I'm reading from left to right. Negative 3 divided by 5 is a negative 0.6. Using my asymptotes as a guide, I just curve those. Then between negative 2 and my point that was at 0, 0 on the y-axis is a negative 1. Negative 1 divided by negative 3 is a positive 1/3. So I'm confident to say I'm going to go above, cross, or bounce at 0, 0. To find out if I cross or bounce, I'm going to substitute a value of 1. 1 squared minus 4 is a negative 1/3. It does cross. Trying to make a smooth curve. Then I'm going to try the value of f of 3. 3 divided by 9 minus 4 is 3/5, which is positive, above the line. Again, I'm going to use my asymptotes as guides to where I graph and curve. All right. I have just a couple more examples to show you. We still go through the same steps. The vertical asymptote, x squared plus 1, set it equal to 0. X squared equals a negative number means this is an imaginary number, so there is no vertical asymptote. On the horizontal asymptote, the x to the 1 power, 1 is smaller than 2. We're going to start at y equals 0. To find the x-intercept, I set the numerator equal to 0 and solve. X is 0, 0, 0, then it's both my x and y-intercept. Remember, y-intercept, you set or substitute all of the values of x as 0, and 0 divided by anything is 0, so we are at 0, 0. Since I have not seen a graph like this before, I'm going to just start plugging in values. The y equals is the only horizontal asymptote I have. 3 times 1 is 3. Divided by 2 is 1.5. I'm going to jump to 3. 3 times 3 is 9. 9 plus 1 is 9/10. 9/10 is almost to 1. Then I'm going to substitute a negative 1. Negative 3 divided by 2. At negative 1, I'm down here to negative 1.5. I'm going to jump to a negative 3. Negative 9 over 10 is negative 9/10. So I'm almost back. Now, if you weren't sure how this would go, you would go ahead and plug in, say, a value of 5. And what you're going to see is this value is going to get closer and closer to our y equals 0 line. There's only one x and y-intercept, so it's going to cross and go closer and closer as you go left. And our last example, vertical asymptote. Always set that denominator equal to 0 and solve. We have a vertical asymptote at x equals 2. Using a straight edge, draw in your line. The horizontal asymptote, we've looked at cases where the exponent is the same and where the exponent is smaller on top than the bottom. Since the 2 is bigger than 1, there will be no horizontal asymptote. It will be oblique or slanted. And we need to find the equation of that curve. X squared, 0x's minus 1. I'm going to use the synthetic division to discover what my equation is. And since this was an 1x squared and we divided 1x out of it, this is x plus 2. The remainder is minuscule. We're not going to worry about that remainder. But this is an equation y equals mx plus b. We're going to start at our y-intercept at 0, 2. Our slope is the number in front of the x1. We go up 1, right 1, up 1, right 1, and we're going to connect our dots. This is the same idea that we've been dealing with in 9.5 and 9.6. I have a vertical asymptote, and instead of horizontal, it's slanted. But I still have two parts of this graph. I have my domain values to the right of my vertical asymptote of 2 and to the left, and I just need to find out what the values are. If I find my x-intercepts, I set the numerator equal to 0 and solve. X squared equals 1, take the square root. I am at 1, 0 and negative 1, 0. The y-intercept is where I substitute values of 0 everywhere there's an x. And this is the first one we see that it is not 0, 0. We are at a positive 1/2, 0, and a positive 1/2. Now that gives me 3 points on this curve, so I am confident in saying that using my guide, I know what's happening then to the left of the graph. I need to find out what's happening to the right of that x equals 2. To do that, I'm going to plug in values that are to the right of 2 into my domain. I'm going to try 3 first. 3 squared is 9 minus 1. 3 minus 2 is 1. 8 divided by 1 is 8. 1, 2, 3, 4, 5, 6, 7, 8 is way up here. If I extend my dotted lines out, I'm going to use those as guides going through my point, turning and going back up. and I hope this video has been helpful.